And welcome. So in this experiment we will do house wiring, that is experimental setup of domestic wiring with a fuse and miniature circuit breakers. So this is the experiment name, and we need all these things. These are all the various equipments we need for power supply, MCB, miniature circuit breaker, and these are all the fuses, various types of fuses, and this is main switch. We know that lamp holder, and socket, three pin socket and 3-pin plug. These are all the basic items we need, and you can able to read these things, and while seeing the circuit diagram for this experiment, we need a power supply. Okay, we are only concentrating on single phase circuit, and single phase 230 volt 50 hertz. This is AC power supply. This is MCB, miniature circuit breaker. What we need is actually this is a simple domestic wiring, where we are having two lamps. This is the symbol of lamp, lamp 1, lamp 2, and each individual lamps are having their own switches. Lamp 1 is having switch 1, lamp 2 is having switch 2, and the entire system is actually controlled by means of this MCB called miniature circuit breaker. We will call it as main switch, and also fuse. We need a fuse for this, and this is very important to protect our entire system from the high flow of current. Okay, so the fuses, this is actually our KitKat fuse. We will call it as a protecting device. That is actually a high amount of current should not enter into the devices. If suppose the above the rated amount of current is flowing through the lamp 1 and lamp 2 means, I mean in this path, if suppose the high amount of current is flowing means this lamp 1 and lamp 2 will get damaged. So in order to protect this fuse elements is actually helping, and this is our supply main, and this is our rough diagram, and technically speaking, we need to look at this circuit diagram. Okay, this is our entire house wiring setup. Actually, we are looking for 3-phase house wiring setup, and we are having energy meter in our home, and from the post itself we are receiving the 3-phase power supply. If suppose we are having 3-phase power supply means this is the circuit diagram, and this is the pole. Okay, so from the pole itself we are receiving the 3-phase power supply, and it is given to the energy meter. From the energy meter itself, it is actually collected. We are collecting 4 wires, that is R, Y, B, that is 3 phases, 1 neutral, that is 4 wires we are getting from as output port of the energy meter. By means, whatever the appliances we are using in our home, like either it may be a socket or a lamp or a fan. So the entire, if suppose we are using 3 individual loads, okay, the actual energy what we are consuming is actually 24/7. It is measured by this energy meter only. So that is why the EB peoples or the technicians is coming to our home for every 2 months of period, and he is noting this reading. Okay, so this is how the entire setup will look like this, and after receiving the output from the energy meter, okay, so it is given to the overall supply mains, that is it is so called 3-phase isolator. So if it can be on and off, so the entire system is getting switched on and off, and from this switch itself we are getting the same 4 lines like R, Y, B and black. So this is neutral. You can be able to see this neutral pin, right, this black color line is taken out from the particular isolator, and it is travel over here, like for each and every room. Let us consider this is room 1, room 2 and room 3. Okay, so this black color cable, that is neutral, is going to all the room like this. Okay, room 1, room 2 and also room 3. Okay, so and also for all the appliances, the neutral is very essential, because this is the way the circuit is getting closed. You can able to see here. So the phase is flowing through the switch and then lamp, and then it can return to the neutral itself. This is actually a closed path. Okay, a circuit has to be closed, then only the flow of current will be started, right? So this is the closed path. So likewise, so for each phases R, Y, B, so whatever may be the flow of current, but it has to be closed, right? So the neutral is actually distributed to all the rooms. Here room 1, this is going to a separate switch for this room. Okay, this is a miniature circuit breaker for this room. Okay, in order to protect the devices. Okay, if suppose any fault occur in this room, no need to go for the switch, main switch, and no need to switch on off this switch. Okay, automatically this miniature circuit breaker will trip off it. Okay, so this neutral is going through this MCB and also going through the socket. Okay, then by the way it will close here, right? Then this neutral is going through this room 2 miniature circuit breaker, and it is connected with the device, right? A bulb, right? So this neutral is going through this room 3 miniature circuit breaker and going to the lamp. So finally it will be connected with the device end. That's all. Okay, so this neutral, you can able to see the neutral is connected to the device end. That's all. The neutral is connected to the device end, one end of the device, right? So the phase is always connected with the switch. Okay, so always keep note. Okay, see the phase, I mean RYB, this is RYB, it is having a rotary switch. So okay, I will show the parts here. Okay, initially we will look at the circuits first. So always see, look at this. So the devices and the switches, the phase is always flowing into the always meet the switches. Okay, then switches to the devices. Okay, so please keep note here, the yellow phase is coming out of here. Okay, so this is red phase. Okay, red phase is traveling through the MCB and meet the switch. Via the switch the device will get the power supply. Then only we can able to turn on and turn off the device, right? So the yellow phase is also coming through the miniature circuit breaker and meeting the switch, and through the switch only the device is getting the power supply. Similarly, this blue phase is coming out of this switch and also going through the MCB and meeting the switch, and from the switch to the fan. Similarly, in our circuit diagram also, that the phase to switch to lamp, this phase to same switch to lamp. See, these are all the parallel connections. All the devices, if suppose we are having 10 lamps, lamp 1, lamp 2, lamp 3, lamp 4 up to lamp 10, everything should be connected in parallel manner. This is so called parallel configuration. Okay, voltage, if you are giving 230 volt, means if you are connecting all the devices in parallel, okay, this may be one lamp, this may be one fan, this may be one AC, whatever may be, this 230 volt will be parallelly giving for all the home appliances. The voltage will be same, current will be different. In parallel circuits, voltage will be same, current will be different. Okay, so this is the entire actually domestic wiring diagram. You can able to see energy meter input, energy meter output. This is for 3 phase. These are all the hardware part. This is main circuit breaker. You can able to see there are 4 wires: neutral, R phase, Y phase, and B phase. Okay, so there are 3 individual rotary switches: R phase, Y phase, and blue phase. And there are individual indicators is available: red, yellow, blue. Okay, so you can able to see 3 phase changeover. This is nothing but actually we are using all the electrical appliances as single phase devices. Okay, so if you are suppose we are using 3 phase devices, means we can use multiple in our home itself. We are using AC, air conditioning system, refrigerator, and microwave oven. Like means the heavy load we are using means certainly we need to move for 3 phase AC supply, and it is having a different tariff when compared to single phase. So if you are getting 3 phase supply to our home, this rotary switches will be automatically we need to fix. Okay, it is mandatory. Then only we can able to connect red phase to the room 1. Okay, you can able to see room 1 odd phase. Okay, for the sake of understanding, there is a mini circuit breaker is available, one specific switch box is available, right? So with the Y phase itself, we are connecting a room 2. Okay, Y phase room 2. This is actually comes with a separate circuit breaker for this room, switch and the lamp. Okay, yeah, this similarly the blue phase, this is directly giving power supply to room 3, that is B phase, and a dedicated mini circuit breaker as well as a switch. Okay, you can able to connect a fan with this. Okay, so with the help of a 2-pin plug, we can able to connect a table fan or a ceiling fan. Okay, so this is the entire setup. Okay, so what we are going to do is, now we are going to I'm going to connect only single phase. Okay, we don't need to bother about single phase or 3 phase. We are showing the results for single phase. I'm connecting yellow phase and neutral. Okay, I'm switching on. Okay, there is a power supply is coming out from this port, single phase. Okay, this indicates this is fuse. Okay, so you can able to see this is in off condition. Okay, I'm turning on. Okay, while red, yellow, blue. Okay, so if I'm suppose I'm turning on the yellow phase, the yellow indicator is turning on. Okay, so the power supply is coming from the switchboard to this MCB, and then here the rotary switch, and I am switching on this rotary switch. Okay, this position, this is the actual position for this yellow phase, and now the switch is already on, right? The miniature circuit breaker for room 2. Okay, just I am switching on the device, the lamp is actually glowing. Okay, if there any fault with the lamp, okay, I am wrongly connecting the terminals, means automatically the MCB will be trip off. Now I manually tripped off. Okay, so in case of any failure, in case of any malpractice, that is any short circuit, if it is found in this room, okay, there is no more, it will not be affecting room 1 and room 3 devices, because the room 2 comes with a separate MCB. Okay, it can be also manually operated or automatically trip off. Okay, tripping off of this MCB is actually automated. Okay, if suppose there is abnormal current is flowing through this MCB, automatically it will trip off. Okay, so if there is any problem with this room, okay, if this within room 2 if there is any problem, automatically this MCB will trip off. Okay, you can exclusively go to room 2 and we can inspect what devices is actually fault. Okay, if without this MCB, what will happen, the main MCB will trip off. Okay, then if there is any fault in room 2, room 1, room 3 will also not receiving the power supply, because there is no more protecting devices for room 2. Okay, for individual rooms there is no more protecting device. So only our entire electricity, domestic wiring comes with a main circuit breaker, main MCB and sub MCBs. So we will call it as tripper. Okay, so it is manually, we can able to switch on it manually, and manually we can able to switch off. In case of any problem with this room, automatically this tripper will get trip off. Okay, so this is actually dealt with the Y phase. Okay, so now we will remove this yellow phase, right? And I'm connecting I'm connecting this red phase. Okay, just I'm connecting the red phase. Okay, and I am switching on the device, switching on the supply, and I am connecting, and also turning on this red phase. You can able to see the red phase is switching on now. Okay, now you can able to realize. Okay, okay, you can able to connect charger. Okay, so just I'm powering up my device, it is now getting charging. Okay, okay, so this is the concept behind domestic wiring. Okay, so this is the actual setup for the domestic wiring. So by the way, we can able to understand this is the concept how we are distributing the power for all the appliances in our home.